I've been asked today to talk about ocean observing around South Africa and what data is available. So I've put together this presentation, but I should really just emphasize that it's focused on the work we're doing at the National Research Foundation South African Environmental Observation Network, and also the South African Polar Research Infrastructure. And I've put here on the slide some of the key partners, so the Department of Science and Innovation and the Department of Forestry, Fisheries and the Environment, and some of the universities, but this is not to be taken as a comprehensive overview of everything. We're doing incredible ocean observations in South Africa. We're cutting way above our weight internationally, and it's just impossible in a short time to fit it all in. So yeah, more or think something's missing, just please feel free to contact me. So a little bit of an introduction to SAEON, observations on South Africa's biomes. But today I'm only going to be focusing on coastal nodes. So this presentation will talk about the marine offshore, and then the second half will talk about the coastal work.
Juliet, your connection is quite erratic. Okay. So maybe just put your video off.
Apologies for that. I'm in the office, but it must, yeah. So hopefully it'll survive.
No problem.
And really our aim is to advance our understanding of the marine offshore environment and our ability to detect, predict and react to global change through long-term observations, research and data. So really the government in about 2005 really understood the importance of sustained long-term observations, and this is when SAEON came into place. We also host the South African Polar Research Infrastructure, which is one of 11 Department of Science and Innovation funded research infrastructures. And the goal of SAPRI is research for technicians, engineers, scientists of all disciplines, government, private business, and to really accelerate the implementation of the Pan-African science, technology and innovation agenda. So that's a little bit about where. So I think a lot of you really understand why we're monitoring the ocean, but I'd to highlight that again. Perhaps there are some people there listening who aren't. And this from Craig McLean at NOAA is a really great one. If you like your weather forecast, thank an oceanographer. Basically, you know, the ocean really impacts on our climate and weather patterns. And so we really need to get information from ocean exploration, which can help us understand not only how we're affecting, but also how we're being affected by changes in the Earth's environment. Ocean observing also gives us information to keep coastal communities, economies, and ecosystems healthy. And through ocean observations, we can deliver early warning hazards like tsunami warming, storm surges, and extreme waves that Andrew's been talking about. And this can help save lives and enable marine operators to remain efficient. And, you know, really looking to the future, a sustainable ocean economy really has potential to be a major source of food, jobs, and energy in South Africa, as we've heard a little bit about. And then just focusing in a little bit on what's happening in South Africa's EEZ. You know, we've got a lot of marine protected areas. We've got extreme oceanographic conditions, deep sea drilling, oil bunkering, aquaculture, renewable energy. So Andrew's touched nicely on some of that. So that's just really focusing on what we've going on in our EEZ and why it's so important that we understand the oceans around us. So this animation is for those of you who aren't familiar with what kind of incredibly dynamic system we're working in. So obviously we've got South Africa, and here is the sort of Agulhas Bank and the continental shelf. And you can see you've got just so many different eddies and mesoscale features happening all around our coastline, making it not just incredibly dynamic, but incredibly difficult to carry out observations. So this is just a schematic of what I've just shown you. And it really highlights, we have the Greater Agulhas Current coming down on our east coast. And this is a western boundary current. And what happens is this current brings warm and salty water along the coast, and because of that closeness of the warm water to the South African coast, it really influences the local weather systems. But not only that, it comes to the bottom of South Africa and does what's called a retroflexion. So it just does this great big loop and heads back into the Indian Ocean. And here it sheds what are called Agulhas rings. And these carry heat and salt into the Atlantic Ocean, and they carry this heat northwards, and that really impacts what's called global thermohaline circulation, which is really kind of one of the drivers of our climate systems. We also have the Benguela current, this cold upwelling current, which supports our fisheries, and all of these mesoscale eddies, which are shown here by these circles. So as I said, it's incredibly complex to observe all of these many different features, but it also makes it just a fantastic place to do ocean observations. So what ocean observations do we undertake in South Africa? So we have Argo floats, which are sort of autonomous marine robots, which get put in the ocean and take ongoing measurements over their lifespan of temperature and salinity. We tend to deploy a lot of those on behalf of other countries in our water because they're very expensive to buy, but we will be purchasing some soon. We have these are gliders. These are like, I guess they could be compared to underwater drones, and they're controlled. And we have a few glider experiments that have been run on the east and west coast. And then the CSIR has a program using gliders in the Southern Ocean, but there's really no sustained observing transects, and our glider fleet is really getting quite old. We also have XBT lines, expendable bathythermographs, which are taken on cruises, and they measure the temperature. And there's a sustained line which comes out of Durban, but again, that's run by Scripps Marine Institute. And we have a number of state-owned vessels. I don't know, I see Ashley is talking a bit later, so he might touch on this, but these are all managed by the DFFE and do various ongoing research cruises to support our oceans economy, but also to support the fisheries. And we have a lot of coastal observations, but as I mentioned, I'm going to talk about that in the second part of this talk. So we also have mooring arrays. So these are ocean observing equipment that are put in the water, and they run from just the subsurface right down to up to 3,000–4,000 meters. We have a line which goes through the Agulhas current, which was run from 2015 to 2018, but we had to take it out of the water due to various issues, which I think in the end was quite fortunate during COVID, or else we would have lost a lot of the instrumentation. But we're hoping to put it back in the next couple of years. So that's really sustained observations of the Agulhas current. We have the Samba array, which is run through DFFE and Dr. Taryn Lamont, which is a mooring array in the west, off our west coast in the Benguela, and that feeds into a larger international program across the whole of the South Atlantic. The Good Hope line is no longer in the water, unfortunately, and then Crossroads is also XBTs and CTDs, but no moorings yet. And I think that the thing to highlight here is that all the moorings in the offshore are linked to research grants, and they're not sustained. But Samba is really the longest running that we have. So at the Igagazini node, the SAEON Igagazini node, we focus on multidisciplinary observations, but also in working towards operational oceanography. And so we have a strong modeling approach. And I'm not going to focus on that much today because the idea was to look at ocean observations, but really just to highlight that modeling is a key component in the end-to-end value chain of ocean observations. So some of the other projects that we do, I mean, it's a very large area that we're looking at. So from our EEZ out into the South Indian and South Atlantic, and the Southern Ocean, because all three of these ocean basins influence what's happening in South Africa. And I just wanted to highlight that one of the projects that we're looking at is the impact of the Kinklet Ridge, which Andrew so nicely spoke about. And we're looking at how that ridge that he highlighted is impacting on the local oceanography and how it interacts with the currents and how that impacts local fisheries. We also look at much broader scale impacts such as ENSO, the Indian Ocean dipole, and general warming in the ocean, and how and marine heat waves, and all how that influences South Africa's weather and climate, the fisheries and coastal communities. So what is our future in terms of ocean observations? Really, as I mentioned, the government is committed to sustained ocean observations of essential ocean, climate, and biodiversity variables. Really, in order to unlock the potential of our ocean's economy and to understand the incredible coastal and offshore features surrounding us. And I just wanted to note at this point, Andrew highlighted his disappointment at the lack of the multi-beam that he needs so desperately to carry on with his work. And I think it is important to highlight that with DFFE, and again, I know Ashley is talking after this, that the SAPRI is actually in the process of buying one of these multi-beams. We've understood the needs, and so hopefully, Andrew, that alleviates your disappointment. The problem is with all things like this, you know, you're looking at a piece of equipment that costs around 8 million. And to get it installed onto the Agulhas 2 is quite a complex thing, because we need to get a naval architect to assess the ship and where the multi-beam is going to be placed, and whether that can actually even be achieved in South Africa. And then it all has to align with the Agulhas 2's dry dock. So it's a very complicated thing, but the government is committed to providing it. So hopefully in the next couple of years, we'll be able to see a lot of new data coming out that Andrew can be working with. We also have, I just wanted to highlight a pilot project. I spoke about the Agulhas moorings. So through the Global Ocean Observing System co-design program, we're looking to co-design sustainable ocean observing solutions for 6 societal issues: tropical cyclones, marine heat waves, boundary currents, storm surges, marine life, and carbon. And all of these really are a key part of the Agulhas observing system. So while understanding the boundary currents around South Africa is critically important, each boundary current, the Agulhas and the Benguela, has unique attributes and impacts to South Africa. So we're working on, so the important thing about a co-design project is working with all stakeholders to make sure that the observations that we do are relevant and that the data is accessible. So that leads me on to data. And, you know, we can produce a lot of ocean observing data, but, you know, you really need to be able to ensure that it's accessible and that it's understandable. So SAEON has an observation database and an open data platform, and a dedicated node for data management to ensure that data is findable, accessible, interoperable, and reusable. And it's a trusted repository of environmental data and has the Core Trust seal to align with international platforms. But underneath here, I've also highlighted the Marine Information Management System, which is part of the DFFE's Operation Pikisa. And so all of our marine data goes into MIMS and is accessible by, and is openly accessible. But of course, having that data is nice, but it's really the impact that we make with that data that's going to make it valuable. So, and I'm running, I want to finish up now because I've got to move on to the coastal observations. And again, Ashley might talk about this. South Africa has the Ocean and Coastal Information Management System, which is really leading globally in terms of what it's doing in terms of data products and information. And that's run by Marjolaine Krug at DFFE. And here it's science aimed at societal issues and in support of institutional decisions. Part of Operation Pikisa also is the South African Marine Resources Exploration Forum, whereby we work closely with the oil and gas industry to ensure maximum research can happen through the cruises. And we also do impact through things like the Indian Ocean Rim Association, whereby we really can help impact on policy. But again, all of this, as I mentioned at the beginning, it's not just run through SAEON, it's run through many of the collaborators that we have, both nationally, regionally, and internationally. And we also work very hard on capacity development and growing the next generation of marine scientists. And so I just wanted to highlight Seamester, which is run by Isabel Anzorg, and that takes students from all across South Africa to sea for 10 days every year, and get in touch with her if you want to know more about that. We have a strong science engagement program whereby we help learners and teachers to understand more about ocean sciences. And I've put this up, but I know Ashley's talking about it, so I'm not going to go into it in the interest of time. But given all this is talking about United Nations Oceans Decade, I wanted to highlight that within Africa, we have a dedicated task force to implement the Ocean Decade Africa Roadmap. And we have 9 priority decade themes for Africa, and also an umbrella decade program for Africa. And I'm part of the task force. So if anyone wants to know more about what is being done within Africa in terms of the Ocean Decade, please just contact me. So I'm going to say thank you for that. And I'm going to pause for a moment, if I may, because the next presenter, Prof Tommy Borman, couldn't make it. So I'm actually going to give his presentation. So I don't know if I can pause briefly for questions and have a bit of a break, or do you want me to go straight on?
Well, you were sharing the session with Tommy Borman anyway. So I think you should go ahead.
Okay, perfect. So I'm just going to share my screen again. And hopefully you can see Tommy's presentation. So what I'm going to do now, I've spoken about the offshore and what's being done there. I'm just going to move briefly now into the coastal observations that are happening in South Africa. So SAEON, as I mentioned, established the concept of long-term observations, and the sentinel site of Algoa Bay was set up in 2008. And the data and platforms at the site became popular among local, but also among international researchers. So the DSI included the expansion of the concept to other areas in South Africa through this research infrastructure, the shallow and marine coastal research infrastructure. And so far, the KwaZulu-Natal Bight has been rolled out, as you can see here, and we'll shortly be rolling out the Two Oceans Sentinel site and also the Marion Sentinel site in 2024 and 2025. So this research infrastructure includes new sites for long-term observations, but also the establishment of numerous other coastal research platforms with a national footprint. And I'll go into a bit more detail, but really to highlight that these major Sentinel sites are here, but there's also these other sort of more satellite areas. And then to note as well that the central coordinating unit is in Quebec. So of the 15 platforms that are funded by the SMACRI, 12 are managed by the SAEON Ilwandle Coastal Node, and you can see those here, and 3 by the South African Institute for Aquatic Biodiversity, and those ones are shown here. And you can see that some of them are centralized in Quebec and at the Sentinel sites, and then there are these distributed ones, and I'll go into a bit more detail about that. So this image just shows the Algoa Bay Sentinel site for long-term ecological research, and it was established over 15 years ago, and there are more than 15 million observations that have been collected by the in situ observatories. So each of the symbols in this map show the location of a long-term in situ mooring that record data on an hourly basis, and that makes this bay one of the best observed coastal areas in the world. And this comes back to what I was saying about South Africa really punching above its weight internationally. So at the Sentinel sites, we observe a range of the essential ocean variables and essential biodiversity variables at different temporal and spatial scales. And those are just shown here. And depending on the coastal habitat and the rate of change one can expect to occur in an ecosystem makes it dependent on which EOV and EBV are measured. So over and above regular observations, which are hourly to once a year, SMACRI also sample extreme events such as floods, storm surges, HABs, marine heat waves to ensure that they capture the impact of these events on the coastal ecosystems and society. So I spoke about the moorings in the offshore, but you also get these more coastal moorings. And up until now, they've all been subsurface. So there's nothing at the surface. So you can only access the data once you've been and downloaded it from the mooring. So that's kind of every 6 months. But real-time or near real-time really is important in terms of search and rescue, maritime safety, and weather forecasts. And you can really use that data in near real time to act on it and to improve the science that we do and to ensure the safety of people at or near the ocean. And through SMACRI, they're in the final stages of developing these two types of moorings, of surface moorings. These large moorings shown here on the right will be deployed in 5 or 6 selected key coastal areas, and they'll be equipped with the latest state-of-the-art oceanographic sensors. And then these smaller moorings shown here on the left will measure temperature and waves and swell, and will be deployed more frequently along the coastline of South Africa. And the plan is really to start deploying these moorings early next year. So that's talked a lot about water measured by sensors, but there's also a large data collection through biological sampling and water sampling. And this is done in the labs at Quebec for analysis. And SMACRI have established a suite of coastal biogeochemistry labs at Nelson Mandela University, where they're hosted. And these are equipped with state-of-the-art instruments to analyze seawater for nutrients, chlorophyll A, carbon, heavy metals, microplastics, alkalinity, phytoplankton, zooplankton, amongst others. So obviously, with all of this, there's a need for infrastructure and platforms to collect samples from under the sea. And SMACRI operate and manage a research dive unit equipped with a hyperbaric chamber and access to an 8-meter dive tank on the Ocean Sciences campus. SMACRI have entered into a public-private partnership with a diving medical practitioner that operates and runs the chamber for them, which really helps them to focus on collecting samples and doing underwater research. So you can see this is the hyperbaric chamber here at Nelson Mandela University. So SAEON is also part of the Estuaries Monitoring Network and is currently responsible for the long-term observations in 10 estuaries in South Africa, with expansion planned to a further 6 estuaries around the coast. Observations in the estuaries include in situ sensors, and you can see here, this image shows changes in salinity in one of the estuaries, as well as pelagic ecosystem observations, sediment changes related to sea level rise, and blue carbon stock monitoring. One of the most requested data sets from scientists is the SA National Coastal Temperature Network. And this is a network of 173 shallow subtidal underwater temperature recorders around the coast of South Africa that record data at various temporal scales. And that really depends on the logger or the partner who's running it. So this image just shows some of the UTR data that assists scientists to understand the variability in ocean temperatures and the major impact it has on our marine biodiversity. And so you can see here, you can pick up when there's major changes in temperature. As part of SMACRI, they also established the Airborne Remote Sensing Platform, that consists of a small light sports aircraft, which is equipped with the latest advances in airborne remote sensing and enables them to collect high-resolution orthophotos, LiDAR imagery, which is centimeter-level topography, infrared and thermal imagery. They're also hoping to procure a hyperspectral sensor in the near future to repeat the surveys, which are currently being conducted by NASA through the Bioscape program. And that's in fact where Tommy is right now. He got a call yesterday that they had an opportunity to do some sampling today. So that's why I'm giving this presentation on his behalf. In terms of coastal craft, the South African Institute for Aquatic Biodiversity, funded through SMACRI, managed 3 of the larger coastal craft that are based out of Durban and Quebec. And these vessels can do very similar things to a large research vessel at the fraction of the cost, but are constrained to being, very much within our EEZ and inshore of the Agulhas Current. They're also equipped with multi-beam sensors, which we've heard about, to map the seafloor in high resolution. The other SIAB platform is the Marine Remote Imagery Platform that consists of a suite of innovative instruments that collect video imagery of various underwater habitats. These instruments include ROVs, SBRUVs, jump cameras, and deep landers that can operate up to around 1,000 meters depths. And from then on, sort of beyond 1,000 meters depths, that's when we have the Igagazini node and SAPRI stepping in to do the underwater imagery. And these videos are used for biodiversity assessments, stock assessments, and exploration of the marine, exploration and also marine biodiscovery. So a main focus of the underwater imagery platform is really to better understand the benthic ecosystem, particularly at depths greater than those that scientific divers can safely operate at. And the last SAEON platform is the Acoustic Tracking Array platform. And this consists of a network of acoustic listening stations around the coast of South Africa that observe the movement of tag species, mostly fish, but also sharks, rays, and turtles. The platform in South Africa forms much of a larger global tracking array network, which you can see in this image. And that's really been key in understanding the global migratory patterns of marine species, such as the great white shark. And then coming back again to the data, as mentioned, one of the main pillars of SAEON is making our data accessible. So we've developed numerous databases where all of the data can be searched, queried, and downloaded, and it all adheres to the FAIR principles. And we can also mint DOIs for data sets. And we're also working now to produce and create data products. So that's the end of the more coastally focused presentation. And I'm going to stop sharing there.